Assalamu alaikum and hello everyone. This is Aliedani Ahmed. Today, me and my group will present and showing the Airbus A350 flight control system. And we hope that this video will be useful for you to understand clearly about A350 flight control system. So, what we are going to present now. Here we have the Airbus A350. The A350 flight control system, which including the flight control laws or modes, and also flight control surface device, and primary flight control system and slats flaps control system. First of all, we have a flight control laws or modes. The relation between the flight crew inputs on the side stick and the aircraft response is called control law. Actually, here we are talking about the computer on board the aircraft that are going to give a command order based on sensor inputs, whether it's coming from the pilot or from any other sources. So for the flight control laws or modes that we have four different laws in the flight control system, which is normal law, alternate law, direct law, and also abnormal law. For the normal law, the main objective of the normal law control law are to provide comfortable handling characteristic and to provide comfortable to the passenger and crew. The normal law meaning that the primary and secondary computer are receiving inputs and giving command for protecting the aircraft in all different kind of ways. For example, rotation, low takeoff and load factor protection, also angle of attack. So the normal low is the computer protecting the aircraft from high speed problems, basically protecting it from installing and etc. So for the normal low, we have a rotation low, which is to minimize the risk of the tail strike, and also pitch normal low, which is to control the flight path of the aircraft through a load factor demand to secure the flight involved. So as we can see here, the pitch normal low. And also secondly, we have a flare low, also to provide an aircraft behavior similar to the one of the conventional aircraft during the flare, to enable a precise control of vertical speed and touchdown point. So this one is when the aircraft try to landing at the airport. And here we have an example for the normal low during the flight. As we can see now, how is it work? Alright, and now we are showing the flare modes. How is it work before landing? And what's the relationship between the elevator? And also for the normal low, we have a protections. We have high speed protection to limit the possible speed, explosion point, whatever stick input. And also we have pitch altitude protection, which is to enhance the effectiveness of angle of attack, and high speed protection in extreme condition. And also we have angle of attack protection to ensure safe flight and good handling characteristic at high angle of attack. Second part that we have for the modes, which is the alternate law, which means that you are going to have a failure on the computers or a failure on something. The law in alternate law, there could be some variation as to how defining depending on the sensors that's failing or not. So here we can see that the normal law is complete protection and the alternate law is non-complete protection. Third part, we have the direct law. There for the direct law, there is no protection, as we can see here. For the direct load, there is no protection coming from any of the computers. The direct load is the lowest level of flight control computers, and also in direct load there is a direct relationship between the side stick position and the elevator position. And for the abnormal low, this is the low where the system is trying to offset any collision or consequences of collision or extreme weather condition or atmospheric condition. As we saw before, the primary computers are going to operate or run the normal alternate and abnormal lows and direct lows. Those all operated in primaries, and the direction abnormal low is in secondary computers. That's mostly for secondary flight control surface device. All right, that's all for the modes or lows. Now I'm gonna let my friend Mohamed Ali to present his part about the flight control surface device, and thank you very much for listening. Assalamu alaikum.
Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Today we were talking about flight control system of A350, and I would like to close my video because I need to show you guys the slides so you can focus and continue and keep on track for the topic that we are really talking about today. And I want to thank my friend that he covered the point that he did before this session. And let me start sharing the screen of my PowerPoint. So what I'm talking about during this part is flight control device. We have two things in flight control device. Number one, primary flight control device, and also secondary flight control device. Primary flight control device consists aileron, elevator, rudder, while we have in secondary flight control device flap and slats. So let's just go one by one and elaborate in details. I will start aileron. We know aileron helps keep the plane in balance when it comes rolling of the plane for both left and right. And also it helps balancing that out. The aileron is allocated on the airplane on the trailing edge of the wing, and again those are just to balance out laterally from the left to the right. It also creates condition of tightening of the lift factor, which has a lot to do with the lift number. Now let's talk about the elevator. The elevator have to do with helping with the pitch. Pitch the airplane kick the nose up and nose down. This located on the horizontal stabilizer at the rear of the plane, and again that's controlling the pitch of the airplane, which is going to affect angle of attack and also the lift of the wing. Rudder. Rudder is affecting the yaw, kind of like pulling, pulling laterally from the right to the left. So that's the difference from rolling, which dips downward to the right or left. The yaw is keeping you, at the same axle moving right to the left. This controlling the service controlling advisio, so keeping the plane more centered, and also the B factor also not the primary control used to turn the plane. What the rudder doing when the rudder is moving, it is changing the airflow as many of the control devices are doing. It's actually what all of them are doing, but depending on the position are located on the plane. It's going to have a different effect, and here is doing the same thing with redirecting the air passing the fuselage. So those are your basics. Just think of AER, which is aileron, elevator, and rudder. Okay, that's your aileron, elevator, and rudder comprise your primary flight control system. Together, it will be flight control, primary flight control devices. So it's easy to remember by using these three basic letters: AER. Now, this is some also we can be considered as a part of a primary, helping a little bit. It's your spoilers, uh, which helps with the obviously spoiling the flight of the aircraft. Um, so it's going to create some of drag, but it has a couple of different functions when they can function as some ground spurs, and they have to do with coming in from landing. So now I would like to uh, skip to the uh, secondary flight control devices. Let's start with the flaps. Flaps are going to be affecting the lift. It's sort of high lift device, and its job is to increase the lift of the wing at a certain airspeed. When they are actually extend, and you can notice them if you have been around airplane, you know what I'm saying. But uh, when they are extended, they are increase the surface of the wing. When you doing that, is also creating what we call aerodynamic. When doing that, it's creating curvature, which of course increasing the surface, uh, uh, are as well creating the lift. When it's as a result of doing this, reducing the scaling and the speed, scaling speed, I mean. So gain that's helping when you have an extra lift pretty quickly, which will be at the takeoff, and also in descending, because at that point, when your speed decrease, and you want to have some lift at that point, because you don't have the power uh, behind that when you have reduced the speed. So they are located, these flaps are located on the trailing edge of the wing. All right. So now let's talk about or let's see about the slats. The slats are not located on the trailing edge. They are on the leading edge on the wing. They can high lift devices and creating aerodynamic surveys. They are on the leading edge. They also are reducing the stall speed. They retract normally, so they are not creating drag obviously deployed. They create an interact by doing that, and that's the end of my part. And I wanna pass the microphone, or the presentation to my next group mate. Thank you so much. I appreciate your time and your listening. Thank you again.